Hello everyone. Today we will discuss an concept called vocoders. As the name indicates, it means voice encoder. Actually, it is not only an encoder, it is a decoder as well. So we can call it as voice encoder and voice decoder. So it was actually discovered in 1920s by Howard Dudley at Bell Labs, which has an intention to make it easier to transmit telephone conversations over long distances by reducing the bandwidth. And this design of the vocoder broke speech into multiple bands, that is, the spectrum of speech has been broken into multiple bands, retaining only those necessary of speech intelligibility. So if there are hundreds of frequencies, in that whatever the required number of frequency bands which defines the speech signal properly with intelligible with intelligibility added are retained. So with this, the lower frequency transmission was allowed in telephone lines, and it required a very less copper wire than the full frequency equivalent, thus increasing the bandwidth. So in this way, vocoders were introduced in the telephone lines so as to maximize the bandwidth and minimize the copper usage. But later on, during World War II, the technology has been developed to a level where vocoders have been implemented so as to scramble transatlantic conversation between world leaders. Okay, so it is used for scrambling and encryption. And then the vocoders have been used for artificially generating speech signal combined with musical instruments so as to have a robotic kind of voice, which was used in many of the 1970s and 80s Hollywood music albums. So these are the few applications what we can come across with the vocoder, where we dismantle our speech signal into its constituents like spectrum of the signal, voice decision, then the fundamental frequency of the signal, then use these information to construct a speech signal back with some effects. So that is the idea. So here vocoder is an audio processor that captures the characteristic elements of an audio signal, or precisely what we can say speech signal in our case, and then uses this characteristic signal to affect other audio signals. So we are using some characteristic elements of the speech or audio signal and use that to affect the other signals characteristics. Okay, and thereby we produce a mixed kind of a speech signal with instrumentals, that is music instrumental signals. Okay, so initially this technology was used in attempt to synthesize the speech. Synthesize the speech means artificially generating a speech. For that purpose it was used. That is another important application of these vocoders apart from telephone lines. Okay, then coming to the block diagram, you can see the speech input is given to spectrum analyzer and excitation analyzer. These two blocks are there. They have their own functionality. First one, excitation analyzer generates two kinds of signals. That is, it extracts fundamental frequency from the signal, that is speech signal, where different components of the speech, that is vowels and consonants, have different fundamental frequencies. So all those frequencies will be extracted in the excitation analyzer from the speech. And voicing decision is the another function of excitation analyzer, where the excitation analyzer will decide whether the sound is voiced or unvoiced. Voiced sound is the one which is having a loud sound with say vowels A, E, I, O, U. They are loud sounds. Whereas if you consider P, T, Q, they are not so loud sounds. They are unvoiced. Okay, the pitch is very high in voiced sounds, whereas in unvoiced it is very low. Okay, so that decision is important while we generate the artificial speech signal. So for that we extract that information as well as in the excitation analyzer. Then another part we have is spectrum analyzer. It gives an output of spectrum shape of the signal. It is speech signals spectrum. Spectrum is nothing but the power distribution of speech over different frequencies. That data is given by the spectrum analyzer. Okay, at the decoder end, this is the decoder end, the information provided by the fundamental frequency and voicing decision is used to generate an artificial sound, wherein noise generator is another component used along with the voiced excitation generation. Voice excitation generation. This generator takes input as a fundamental frequency and generates the voice excitations. And to that, noise is added. You can consider this as brass, whereas this one has the hiss. So hissing noise is added so as to give an effect of speech. So when this is added, then the combined signal is given to control filter system, wherein it takes another input from the spectrum analyzer, that is the different spectral components. Using these information, the filter constructs an speech signal and outputs it. So that is the work of decoder. Okay, I hope you have understood this concept. In the description, I have given some of the example musical albums with the speech output as well, for you to make it understand how the vocoder worked. Thanks for watching.